In this video, we're going to be looking at solving compounded interest problems, in particular if they're compounded n times a year or if they're compounded continuously. So we've got well-known formulas for each of those, and we're going to be using those in these problems. So let's jump in with the first one. How much will an account paying 4.9% interest compounded quarterly? So quarterly means 4 times a year, so we're going to use this formula. Okay, so quarterly means n is 4. After 12 years, if the initial deposit was $5,000. All right, so P is the initial deposit or the principal or the starting amount. R is the interest rate in decimal form. So R is going to be 4.9 divided by 100. And we have T is equal to 12. T is in years, and A is the amount after 12 years. So we want to solve this for A. So I'm just going to put this straight into my formula. And then T times N. Okay, so to make this easier on my calculator, I'll just do that. Okay, and so now, these are the easiest problems of all to solve. I'm going to have 5,000, and then in parentheses, 1 plus 0.49 divided by 4, close parentheses, and raise that to the 48th power. Now, how much money are we going to have? Well, money is in dollars and cents, so it's understood we'll round that at 2 decimal places, so the answer here is going to be $8,969.82. Alright, let's look at the second one. How much money do you need to deposit today in an account that pays 7.2% interest compounded monthly in order to have $20,000 in 15 years? So that means we're supposed to find P, find how much we start with. And again, we're going to use this formula. Okay, so we want to find P that pays 7.2%, so R is equal to 0.072. Compounded monthly, that means it's compounded 12 times a year. There's 12 months in a year. In order to have 20,000, so we want to end with 20,000 when the time T is 15 years. So I'm going to put all this information in here. Okay. 0.072 over 12, and then T times N. Okay. So 15 times 12 is 180. So again, I might just make that a little bit easier on my calculator. Okay, so I want to isolate P. So I have P times this, so I'm just going to divide both sides by whatever P is multiplied by. And yeah, it's multiplied by a lot, but you know, it's nothing our calculator can't handle. And so this will cancel, and this is going to be my answer. And so I'm going to put into my calculator 20,000 divided by, then parentheses, 1 plus 0.072 divided by 12 to the power of 180. Alright, so how much would you have to deposit today? $6,813.86. Okay. Now, what if the account were paying 7.2%, but the interest was compounded continuously? Well, then if it's compounded continuously, the formula we're going to use is that. So we want to end with 20,000. We don't know how much we're beginning with, and R is 0.072, and T is 15 years. And again, to get the starting amount, I'll just divide both sides by that. And that will cancel, and this will give me my starting amount. Okay, so what I'm going to do here is do 20,000 and divide it by, do second ln. Actually, I didn't need that. There, I'll just delete that. So second ln gives me e to the power of 0.072 times 15 in close parentheses. Okay, so if it's being compounded continuously, you don't have to come up with quite as much. $6,791.91. Okay, let's look at this third part. How long? Okay, whenever you see the words how long, it means you have to find T, time. How long until you double your money if you invested in an account paying 3.5% interest compounded semi-annually? Okay, for that one, semi-annually, we're going to use this formula. Okay, so you want to double your money. So if you start with P, you want to end with 2 times P. And A is your ending amount, so I want to end with 2 times P. It's paying 3.5%, so R is 3.5 divided by 100. Semi-annually means it's compounded 2 times a year. So N is 2. And we're going to find T, and T times 2. So T times 2, I'm going to write that as 2T. Okay, so now the P's will cancel. And I'm going to be left with, and let's see what's inside there. 1 plus 0.035 divided by 2. It's not too bad, so I'm going to, and don't ever round. Do not round until the very end. Okay. Alright, and what I might do now, there's different ways that you can solve this. I could change it into logarithmic form, because it's an exponential. Or what I'm going to do is I'm going to take logarithms of both sides. Now, my calculator only does direct logarithms in base e or base 10. I'm going to take base 10 of both sides. Now, using the power rule for logarithms, I'm going to bring this 2t out the front. And then I'm going to divide both sides by, well, I want t by itself, and it's multiplied by 2 times t times that. So I'm going to divide both sides by that. And the 2's cancel, and these log cancel, and I'm left with t. So how long will it take? It'll take that long. How long is that in a year? In years? I'm going to do the common log of 2 divided by, then you're going to have to put all of that in parentheses, 2 times log 1.0175, and then, so almost 20 years. So almost 20 years, nearly 20 years, depending on how much they want you to round it to. If it's to 2 decimal places, it'll be that, but almost 20 years. What if it's compounded continuously? If it's compounded continuously, then what we need is that formula. So we want to double our money. And we want to find t. Well, the p's cancel. Now again, I could take natural logarithms of both sides. I could do that. Then using the logarithm rules, that power will come out the front. But natural logarithm of e is just the number 1, so it's 0.035 times t times 1. So to get t by itself, I divide both sides by 0.035. And so if it's being compounded continuously, that's how long it would take. So I want ln of 2 divided by 0.035. Okay, again, you won't have to wait as long, but you know, it's still about 20 years. Okay, so depending on how much it tells you to round it to. And finally, what interest rate rounded to 2 decimal places is required to grow $1,000 into $8,500? So we want to start with 1,000. We want to end with that amount. It's continuously, compounded continuously, so that's the formula I use. T is equal to 10. So I'm going to have r times 10, which I'm going to write as 10r. First thing I want to do is divide both sides by 1,000. And so I'm going to have 8.5 equals that. And I could take natural logarithms of both sides again. Another way is I could convert this into logarithmic form. If you have something like that, then you can rewrite it into logarithmic form. So my base here would be e, and that would be my x inside there equals that. And so ln of 8.5 is that, and divide both sides by 10. And that gives me r. Okay, or I could have taken ln of both sides and gotten the same thing. Now, r is going to be ln of 8.5 divided by 10. That is r. That is not the rate as a percentage. That's r. How do I get the rate as a percentage? You multiply it by 100. And then you round at the very end. Always round at the end. It said round it to 2 decimal places. So 21.40%. So good luck in finding that interest rate, but that's what you would need. And that ends the video.